Hello everyone, this is PCBSYNC. For high-end PCBs, choose PCBSYNC.
Today, we will introduce the definition of layers in Kicad. A PCB is a three-dimensional object made up of different materials stacked together. Let's take a look at this image, which shows a cross-section of a PCB. Although what we usually see is a very thin board, in reality it is made up of multiple layers stacked together. We can see there are copper layers, substrate, and many more. The yellow areas on top represent the traces we designed, and the through holes, pads, or vias run through them, while there are also some blind vias that do not go all the way through. When we usually talk about a two-layer board, it means there are two copper layers sewn on the top and one on the bottom with nothing in between. For a four-layer board, two additional copper layers are added in the middle, and so on. Besides these copper layers, there are also other technical layers, documentation layers, and so on. Before creating a footprint, you need to understand the meaning of each PCB, library, and interface layer. The commonly used layers in Kicad include signal layers, routing layers, silkscreen layers, solder mask layers, solder paste layers, and keep-out layers, among others. So we'll continue using the component footprint we created in the previous video. In the last video, we only placed the SMT pads. This time we'll add a multi-layer pad. By changing the type to a multi-layer pad, you can see in the drawing that this multi-layer pad appears on many layers. Next, we'll set a via size, which will make it easier to visually demonstrate the effects on different layers. First, let's look at the copper layers. The copper layers are divided into the top layer and the bottom layer, which are represented by CU. F and B stand for the top and the bottom layers, respectively, and all the following layers are simple. By toggling, we can see that when it's red, both types of pads have the red layer. When we select the bottom layer, it's blue, and only the multi-layer pad appears there's no SMT pad, because it only exists on one layer. Then, we'll turn it off to show other pads. Next, let's take a look at the silkscreen layer. Generally speaking, the silkscreen layer is the white ink printed on the circuit board. We can look at the picture. These white characters or boxes are the silkscreen layer. In our diagram here, the silkscreen layer is represented by these two types. However, last time we only drew the silkscreen for the top layer. Generally, when creating a footprint, we don't draw the bottom silkscreen unless there's a special situation. So if we turn it off, we can see that once we disable it, all these boxes' annotation lines disappear. But turning off the bottom silkscreen doesn't change anything, because we didn't draw it. We need to pay attention to requirements for minimum distance between silkscreen and exposed copper. And for minimum line width, you can't place silkscreen on a pad, because in that case, it can be printed. Also, there should be no silkscreen under small surface mount components. That is, if the component is too small, you can't draw silkscreen in the area underneath it, because this would negatively affect the reflow soldering process and lead to poor soldering. Next, let's look at the solder mask layer. The solder mask layers are these two layers. As we can see, when switching views, multi-layer pads will have solder mask on the bottom layer. Single-layer pads only have one layer of solder mask. If we turn it off, you notice the color changes once it's off. The color disappears. So, what is the purpose of the solder mask? We can also take a look at some pictures to understand this. This is the effect of the solder mask. Its main purpose is to prevent short circuits between pads or traces. It's basically the green coating we often see on PCBs, but it can also come in other colors, like blue or black. Its first function is to cover the copper traces and prevent the copper from coming into contact with air, which will cause oxidation. If those traces didn't have a solder mask layer, they'd be exposed to the air and oxidation would become an issue. It also prevents solder bridges, which, as mentioned earlier, helps avoid short circuits between pads. These are called solder bridges. Next, let's take a look at the solder paste layer. The solder paste layer actually is not a physical part of the PCB itself, but it needs to be defined on the PCB. Its main purpose is to specify the areas where solder paste should be applied during stencil making and reflow soldering for surface mount assembly. We can take a look at the solder paste layers. They are these two layers, and we can demonstrate this by turning the layers on and off. For SMT pads, this is the final layer once it's turned off. The SMT pads are no longer visible. This is the solder paste layer. Let's see how the solder paste layer is actually represented. It's basically these yellow areas. When we manufacture stencils, the openings are generally determined by the solder paste layer. Finally, when it's fixed onto the PCB and solder paste is applied from above, the paste will leak through these holes and stick to the PCB pads. This is the function of the solder paste layer. Next, there's a board outline layer, which is used to communicate with the manufacturer to define the shape of the PCB. The board outline layer must not intersect itself, and the polygon describing the board must be continuous and closed, since it's the outer frame. If it's not closed, you wouldn't be able to draw the board at all. The board outline layer is also used to indicate cutout slots within the PCB. Generally, the board outline layer isn't used in the component library, but there are some special cases where it might be. Some components require an opening at the bottom. For example, with this component, there might be a post in the middle of mounting poster. It might need to have an opening. In such cases, we need to use the board outline layer, which is what you see here. So we select the board outline layer and place a rectangular opening, and that's it. During production, the PCB manufacturer will create an opening at this position under the component, making it easier to install. Next, there's the adhesive layer. The adhesive layer is mainly used to define areas for glue, and it's only needed when SMT components need to be fixed during wave soldering. Generally, we don't draw this layer. It's only used in special cases. There are just these two adhesive layers. For example, if a component is very light and is prone to shifting during soldering, we can use the adhesive layer here and place a box in this area to select it. This way, during production, the factory will apply glue in this area, stick the component in place, and then proceed with soldering. However, in most cases, we don't use it this way. So, what I've just introduced are the main layers we commonly use. Whether you're designing components or laying out a PCB, these are the layers you need to consider. That's all for today's introduction. If you enjoyed this video, please subscribe to my channel for more content. Thank you, everyone.